Hi, my name is Dr. Deshawn. In this video, we are going to find the second derivative using implicit differentiation. So let's take a look at the example over here on the board. We want to find the second derivative. Here's your notation for second derivative using implicit differentiation. The example I'd like us to take a look at is x squared plus 3y squared equals 5. So you want to start by finding the first derivative. To find the first derivative implicitly, we will just take each term and differentiate with respect to x. So the derivative of x squared with respect to x is just 2x. The derivative of 3y squared with respect to x, bring the 2 around front, multiply by the 3, so that's going to be 6y to the first. Well, that's the derivative of y with respect to x, so you need to write that down because we're differentiating every variable with respect to x. Derivative of a constant is 0. Again, with implicit differentiation, we're going to differentiate every one of these terms with respect to x. So the derivative of an x term, you're going to differentiate, just leave it alone. But when you differentiate a term with a y in it, follow it up with dy dx, that expression. Okay, derivative of a constant is 0. So now we want to solve for dy dx. So dy dx terms stay on the left, and let's move the non-dy dx term to the right. So we have 6y dy dx. We're going to leave this on the left-hand side, and then we're going to subtract 2x from both sides, so move that over to the right-hand side. All right, and then solve for dy dx. And so what do we have for dy dx? Well, let's go ahead and divide both sides by 6y. So you're going to have negative 2x divided by 6y. The 2 and 6, you can cancel 2 into 2 and 2 into 6. So when you simplify, you're going to have a negative x in the numerator and a 3y in the denominator. And here's your derivative in simplified form. Here's the first derivative. Okay, so this is your first derivative. We want to find the second derivative implicitly. All right, so let's go ahead now. So the second derivative, it's the derivative of the derivative. Okay, so we're just going to go ahead and find the derivative of the derivative. Here's our notation. So the notation for the second derivative, all right, here we go with the notation for the second derivative. And let's see, what rule do we want to use? We have a fraction, a rational expression here, so we're going to go ahead and utilize the quotient rule. So you're going to take the denominator, you start with the denominator, which is 3y, and that gets multiplied by the derivative of the numerator. You subtract from that numerator, negative x, that gets multiplied by the derivative of the denominator. It's a y term, so the derivative of 3y is 3, but we're differentiating with respect to x, so you got to follow that up with a dy dx. All this goes over, your denominator is 3y, and you want to square that quantity. So here is your derivative of your the first derivative implicitly. So you're going to take the denominator, derivative of the numerator, minus the numerator expression times the derivative of the denominator. So that's 3 dy dx. All that goes over denominator squared. Okay. So now let's take this second derivative here that we found. We're going to work with it. We're going to simplify it a little bit. So we have, let's go ahead and write our second derivative expression. Okay, here's our second derivative notation. We have a negative 3y. All right, I'm just going to simplify. It looks a bit busy there, so let's simplify. Minus the negative, so let's call this plus 3x and then dy dx. All right, and then all this goes over your 3y quantity squared. Let's go ahead and square that. So don't forget, you got to square the 3 and you got to square the y. So this is going to become 9y squared. All right. Now, what to do next? What we need to do next is we need to substitute for dy dx. We don't want to give an answer, a derivative answer with a derivative in it. So you want to make a substitution and then simplify it out. So we want to substitute. Okay, so what are we going to substitute? Well, dy dx over here, we already found it. Dy dx is negative x over 3y. So that's what we're going to put in here. Okay, so our dy dx, we're going to substitute in negative x over 3y. And so we're going to substitute that in and then simplify it. So let's go ahead and make that substitution. So our second derivative, here's the notation, second derivative, okay, is negative 3y plus 3x times our dy dx, but I didn't write that in there because we're going to make a substitution. All this is over 9y squared. So we want to make the substitution, dy dx out, substitute in negative x over 3y. Let's make that substitution, and now we have to simplify this. Let's simplify this. So our second derivative, here we are with our second derivative implicitly. All right, what do we have? Negative 3y. okay? Now, this term here, when you multiply 3x times a fraction, that's a negative, so you're going to have a negative here, okay? The 3's cancel, so this 3 is not in the denominator, and this 3 is in a denominator, so we can cancel those 3's, okay? So simplify this further. We have a negative x squared over y. Here's what we have. There's our numerator, okay? And the denominator, 9y squared. Okay, so now take a look at this. Your second derivative now, we substituted dy dx is negative x over 3y. We made the substitution and now we simplified. When we simplified, generated a complex fraction. Okay, so we have a complex fraction. We want to simplify this complex fraction. All right, so we don't want fractions and fractions. We want to simplify this. So what do we have here? This term's okay and the denominator is okay, but that y in the denominator, so let's simplify. So what I like to do is just take every single term, top and bottom. We're going to multiply the numerator and the denominator by y. Okay, so multiply by y over y. So multiply numerator and denominator by y. Okay, and then this should simplify out our complex fraction. So second derivative, our second derivative notation right here. Let's see what we have. So now you got to take the y and distribute, okay? So distribute the y, so negative 3y squared, all right? And then we take the y and distribute to this term, and the y's are going to cancel, so minus x squared, all right? That's your numerator. Denominator, 9y squared times y, so that's going to give us 9y cubed, all right? So we're here, okay? So we have our answer here. All right, almost done, but we can simplify this even further, okay? This is a really neat thing, but we can simplify this even further, okay? So let's see how we can simplify this further. Right? And I'm running out of space over here, so just follow the arrows. I'm going to travel over to here, okay? So my second derivative, let me write the notation down. Here's my second derivative, all right? The numerator, I'm going to factor out the negative from the numerator, okay? So I'm going to factor out the negative, take the negative out, okay? When I do factor the negative out, I have 3y squared plus x squared because I'm taking the negative outside. Instead of writing 3y squared plus x squared, I'm going to just turn that around and write x squared plus 3y squared. So I'm going to write it like this. Okay, my denominator is 9y cubed. So we're here, okay? All right, and now what can I do with this? Is one more thing that I can do to simplify, okay? So take a look, okay? It's on the board here somewhere, so look and see what can we do to simplify to come up with our final answer, okay? So here's our notation, second derivative, all right? We're finding ours implicitly. And what can we do here, okay? Do you see, there's one more substitution we can make. Do you see it? One more substitution that we can make, okay? What's that substitution? Look right here in the parentheses, x squared plus 3y squared. Do you see that any place, okay? All the way over here at the very beginning where we started, x squared plus 3y squared. That's our original problem, isn't it? X squared plus 3y squared, it's 5, okay? So you can substitute 5 in for x squared plus 3y squared, okay? So you bring the negative down. This quantity rate, it's in our original problem, it's equal to 5 over 9y cubed. All right, so isn't that interesting? So here is your final answer in completely simplified form with all substitutions, and here is your final answer, okay? So implicit differentiation, all right, and finding the second derivative implicitly, you've got all these substitutions you can make, all right? So how do you implicit differentiation? Just recap really quick. Find the first derivative implicitly. Find the first derivative implicitly by differentiating every single term with respect to x. Derivative of an x, leave it alone. Differentiate to y, followed up with dy dx, solve for dy dx. Then when you get the second derivative, derivative of the derivative, okay, most of the time you're going to utilize the quotient rule, okay? So the low d high minus high d low over low squared, however you work the quotient rule, set up your quotient rule, all right? And then once you set up your quotient rule, you're going to, any dy dx in your answer, you're going to have to substitute. It's most likely going to generate a complex fraction, so simplify your complex fraction. And then once you get everything simplified, look for the opportunity to make that substitution, the original problem, right back into your final answer. All right, so look for that opportunity. All right, okay, well that's it for second derivative implicitly. Thank you for watching, and if these videos help, I would appreciate if you hit that little subscribe button down there. And that's about it. So take care. Thank you again. Bye-bye.